Tidal energy comes from the gravitational forces of the sun and the moon on the ocean's water, creating periodic shift in these bodies of ocean water. These shifts are called tides. Tidal energy. Tidal energy or tidal power is the energy or power produced from tides. Tidal energy is produced by the surge of ocean waters during the rise and fall of tides. This rise and fall of tides is due to the gravitational pull of the moon. Tidal range is the distance between high tide mark and low tide mark. High tide mark means the highest point of the tide, while low tide mark means the lowest point of the tide. The effective tidal range is 8 meters. Remember that moon is much closer to the earth as compared to sun, so gravitational pull of moon is very much stronger than the sun. That is the reason high and low tides are produced due to the gravitational pull of moon. In the first figure, when the sun and the moon are parallel to each other with the earth, then due to combined gravitational pull of moon and sun, high tide is produced in the direction of moon and sun, while the ocean water which is at perpendicular to the direction of moon will produce low tide because that specific part of water is not getting the rays of moon directly, so they will remain at the same position and create low tides in the ocean. In the second figure, moon is perpendicular to sun, so due to gravitational pull of moon, high tides are produced in the direction of moon, while low tides are produced in the direction of sun. So basically it is the moon which is creating high tides and low tides. Electricity produced by a tidal power plant is still in its early stage. The amount of power produced by these power plants are very small. There are very few commercial-sized tidal power plants operating in this world. The first was located in Lawrence, France. The largest facility is in the 𝗲𝗲 tidal power station, which is in South Korea. The world is hungry for the energy. People are seeking for energy to meet up for the future crisis. But oil, gas, coal and some other sources of the energy will be finished within the next 40 years. So renewable energy is the only solution to meet up for the future crisis. So we have solar, wind, wave, tidal, fuel cell, geothermal as a renewable energy sources. Tidal power or slash energy is more predictable than solar or wind and other energies. Rise and fall of tides is more cyclic than random weather patterns. Methods to generate tidal power. Tidal power can be generated via 4 methods. Tidal steam generator, tidal barrage, dynamic tidal power, tidal lagoon. Kinetic energy is used in the tidal steam generator to power the turbines. Working is similar to the wind turbine that uses wind to power turbines. Tidal generators can be built into the structures of existing bridges, involving virtually no aesthetic problems. Land constrictions such as straits or inlets can create high velocities at specific sites, which can be captured with the use of turbines. Shape of these turbines can be horizontal, vertical, open or ducted, and are typically placed near the bottom of the water column. In the figure, you can observe that tidal turbines are placed below the sea level. Tidal stream is coming towards the blades of the tidal turbines, and due to high and low tides of tidal stream, electricity is produced. The pipes which hold the turbines are maybe sunken pipes, concrete blocks, or tripod, which are installed in the ocean floor. The blades of tidal turbine moves in this way. Drawbacks of tidal stream generator. Manufacturing and construction cost is very high due to the limited experience of contractors in installing, operating and maintaining plants. Perceptions of risk are likely to be reflected in the higher cost of manufacturing of these tidal stream generators. Like wind and waves, tidal streams are variable renewable energy sources. Their intermittent generation has implications for large-scale grid integration. The amount of energy tidal stream generates varies over time. Power output of wave energy converters and tidal stream energy generators will also vary. This has implications for grid integration, particularly balancing supply and demand. Tidal barrage. Tidal barrages make use of the potential energy due to the difference in height between high and low tides. In the tidal stream generator, we use kinetic energy, while here we use potential energy. When using tidal barrages to generate power, the potential energy from a tide is stored through the placement of specialized dams. Basically, the difference in water level between barrage and sea is used. Tidal barrages consist of turbine, sluice gate, a basin to store water. During high tides, the basin is filled through sluice gate. In the video, you can see sluice gates are installed in the tidal barrages that can stop or run the flow of water from tidal turbines. These sluice gates restrict the flow of water from ocean when the water in the tidal basin is full. In the left side of the figure is the ocean water from where high tides and low tides are coming towards the tidal turbines, whereas on the right side is a tidal basin which holds the potential energy of stored water. When the water in the ocean level rises and the tide begins to move towards turbine, the temporary increase in tidal power is channeled into a large basin which is behind the dam, holding a large amount of potential energy. With the receding tide, this energy is then converted into mechanical energy as the water is released through the large turbines that create electric power through the use of generator. Barrages are essentially the dams across the full width of a tidal estuary. Security and efficiency of tidal barrages. Tidal barrages are small dam can secure a city. It can protect the city from dangerous tides during a storm. Tidal power is highly efficient. Its efficiency is about 80%. It means that tidal turbines are up to 80% efficient in converting tidal energy to usable electricity. It is said that bigger the power generating equipment, the higher will be the efficiency. As tidal generators are not using fuel, they are more efficient and long-lasting as compared to other generators. Basically, they last for 30 to 50 years. Efficiency of tidal power is much higher than solar or wind energy generators. Drawbacks of tidal barrages. There are notable complications of the energy generation with the tidal barrages. While they generate comparable power to hydropower plants, they also have economic and environmental issues. Necessary infrastructure to build a tidal barrage is cost prohibitive. Tidal barrages negatively affect the turbidity, water level, and ecology of the separated areas. Fish and marine mammals may suffer injuries and death when colliding with the barrages or turbines. Estuaries that are providing breeding spaces for fish may not be suitable for this purpose after construction. Dynamic tidal power plant. Dynamic tidal power is not tried by the world yet, but it is a promising technology that would achieve an interaction between potential and kinetic energies in a tidal flows. Dynamic tidal power plant proposes that very long dams can be built from the coastal areas straight out into the sea or ocean without enclosing an area. Tidal phase differences are introduced across these dams, leading to a significant water level differential in a shallow coastal seas, featuring strong coast parallel oscillating tidal currents such as found in the UK, China and Korea.